or we call it as term 1 exam. Term 1 exam in physics. But the one thing you should understand, the first and foremost thing is never to worry about anything. Whatever you prepared already. So in that now, you prepare thoroughly. Whatever, even a single topic, if you prepare, thoroughly you prepare on that. And never forget whatever the concepts, numerical concepts, derivations. Some students are asking me questions, sir, how much derivations will come? How much numerical will come? What is the segregation? This all the things is not available with the board exam children. Okay. Mostly if you see that. So please never expect that. Mostly I'm telling you, 100% I'm telling you, never expect that more of derivations. The derivations may padikaya, sir, and tomorrow you should not say like this, sir, full of derivations I prepared, almost all the derivations I prepared, but only one derivation, hardly even no derivation there, sir. What to do, sir? So मेरे को डर लग रहा है सर, ऐसा नहीं होना है बच्चों. Understand? So please try to understand everything. I told you that from the beginning. I'm telling you, in one chapter, if you have 10 derivations, out of 14 chapters, minimum 150 derivations are there. Out of 150 derivations, you can expect only one derivation. That is the CBSE board pattern. If I'm wrong, you please check with the previous question paper. So if you analyze the question paper, most of the thing will be based on the concept. Concepts ज़्यादा रहता है. Okay, बच्चों. 1 mark question is there. MCQ questions, of course, and then 2 mark, 3 mark, 4 marks. So many things are there. So please don't I don't want to waste my time because already we are lagging in portion. So yeah, that GA please. And for that now, you should not say that, sir, out of this many derivations, only one derivation. So I didn't prepare the derivations. I'm only preparing the numerical. That's also wrong. See, for NEET exam and for JEE exam only, the pattern is numerical pattern. है ना बेटा, थोड़ा concepts भी पूछ रहे, all in numerical होता है. But in CBSE it is not like that. 1 mark is there, 2 mark is there, 3 mark is there, 4 mark is there. और देखेगा तो बेटा 5 mark questions भी आता है. So please, the child, if you prepare thoroughly, whatever at least we teach you, if you prepare thoroughly now, we proved also for so many years, we proved that how the children are getting more than 90%. 95 in physics, 94 in physics. We showed you also, we proved you also many times. So that the same effort, only thing is you put your continuous effort and memorize all the formulas. Be bold to face the exam. Okay, inshallah, we'll see what the result comes. Now, Bachchan, take down the topic with Ampere circuital. So the first chapter, electrostatics, just I'm recalling. In electrostatics, you remember that we studied the Coulomb's law. So Coulomb's law we played. So इसका modification थोड़ा modify करके Coulomb's law का we studied that modification of Coulomb's law is Gauss law we studied. है ना बेटा? So in the same way, in the 4th chapter, what you studied means first is I taught you that Biot-Savart law. Very important is Biot-Savart. So what is Biot-Savart law? You know the formula dB equal to mu naught by 4 pi ideal center by r square. So in Biot-Savart law, इसका modification only Ampere. So इसका modification is Ampere circuital. So what is this Ampere circuital law? After knowing the Ampere circuital law, we are going to do the same. What is the from the beginning I'm teaching you? The 4th lesson, if you see, the first lesson, if you see, everywhere we talk electric field, electric field, electric field. Second chapter, if you see, everywhere we talk electric potential, electric potential, electric potential. In the 4th chapter, if you see, we are going to talk about the magnetic field, magnetic field, magnetic field. So derive an expression for the magnetic field. So first chapter में कहीं भी देखो आपने अच्छे से याद रखे देखो because exam is there tomorrow. So you know that derive an expression for the electric field due to axial point, derive an expression for the electric field due to dipole at an equatorial point, derive an expression for the electric field due to straight line charge, derive an expression for the electric field due to plane sheet, derive an expression for the electric field due to parallel sheet, derive an expression for the electric field due to thin spherical shell. In the same way, if you see in the second chapter, instead of the electric field, you have to put electric potential. Derive an expression for the electric potential due to dipole at an axial point. Derive an expression for the electric potential due to dipole at an equatorial point. Derive an expression for the electric potential due to a point charge or any general point. Okay, so all these things if you see in the second chapter, but in the 4th chapter, in the same way we studied that derive an expression for the magnetic field due to straight conductor. due to straight conductor. So in the fourth chapter, we studied that there is an expression for the magnetic field due to straight conductor. There is an expression for the magnetic field due to circular coil at the center, at the axial point. So all these things we studied by using the bias. है ना बेटा? तो अपना निकाल के जल्दी जल्दी कम फास्ट इतना सब वरिष्ठ करना लेट आ रहा है ठीक है तो बच्चों clearly you should understand in the first chapter full we studied about the electric field. Second chapter full we studied about the electric potential. Third chapter, current electricity, we studied the different thing that is current circuits, parallel circuits, series circuits, all these things, capacitors. Capacitors in the second chapter, third chapter, Kirchhoff's loop rule. Very, very important that Kirchhoff's loop rule, Wheatstone bridge concept. So all these things we studied in the third chapter. So these are all things now. If you recall, if you think, then you will become number one. You have to
Hello,
think
sir.
and become. Now, in the fourth chapter,
सर आपका बिल्डिंग का कलर कौन सा है?
जल्दी बोलो.
बिल्डिंग का कलर कौन सा है सर आपका?
Abraham, I listen to you above. Okay, this Buhari restaurant, you know, hey, everybody is
कौन
coming
सा?
after 8:30 and disturbing me. Buhari, I'm sending you above. I'm sending.
अच्छा सर.
हाँ नीचे आ रहा है, above नीचे आ रहा है, देखो. Please cut the call. Don't call in this. Hello. Hello, all of you are getting my voice. Hello, 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 hello.
Yes, sir.
Sir.
Yes, sir.
Are you getting my voice? This clever fellow, Abraham. Nonsense. He is calling in this Zoom meeting. Okay, so now in the fourth chapter, we are going to study about the derivative expression for the magnetic field. So in the beginning of the classes, if you see the derivative expression for the magnetic field due to straight conductor and derivative expression for the magnetic field due to circular coil, derivative expression for circular coil में दो option होता है. At the center circular coil में at the center what is the magnetic field? At an axial point what is the magnetic field? At the center means B vector will be equal to mu naught I by 2r. At an axial point means what you will say? Mu naught I r square by 2 into r square plus x square whole power 3 by 2. So like that, now we are going to study one more very important, beautiful law, which is called Ampere circuital law. If you understand this Ampere circuital law, by using this Ampere circuital law, how we are going to calculate the magnetic field. Again, we have to go on the magnetic field one. Okay. So statement. Please take down the statement. It states that the line integral the what states that the line integral of the magnetic field E vector around any closed circuit is equal to mu naught times the current I enclosed in the circuit. Very good. So, बच्चों, all of you please listen. Once again, all of you please listen. Ampere circuital law. What Ampere circuital law says means it states that the line integral. Line means any line if you take circular line, straight line, anyway. So it's the integral line. So the line integral of the magnetic field So here magnetic field, what is here magnetic field, here magnetic field, here magnetic field, here everywhere the magnetic field will occur. And the same way here also, because of straight conductor, how the magnetic field occurs, you know that, by using the right hand thumb. So first listen very carefully. It states that the line integral of the magnetic field around any closed circuit is equal to magnetic field around any closed circuit is equal to mu naught times the current I enclosed in the circuit. The current I enclosed in the circuit. If you write the formula, you will be able to still you will be able to understand very clearly. The line integral of magnetic field circuit integral of B vector dot dl vector will be equal to mu naught times the current enclosed in the circuit. If dot product is there, if I remove the dot product, what should I write here? 11th standard. If I remove the dot here, what should I write? Normal form.
BL cos theta.
BDL.
BDL cos theta.
BDL cos theta. Very good. So Rishit, very good. BDL cos theta. Please come some. 8:45 को आएगा. याद है नहीं ऐसा करता है ना बेटा. इतना डिले करके क्लास बच्चे को दूसरे बच्चे ने टाइम पर पास. हो गया बेटा. So मैं खड़ा था कीबोर्ड में. हैं? वहां पे कीबोर्ड में पूरा कोर्स को क्यों रखा? ये लोकेशन में वहां पर कैसा हम बताएं. So बच्चों listen here. What's in all of you please pay attention here. So Ampere circuit. It states that the line integral of the magnetic field around the closed circuit. Suppose I take this circuit. है ना? So how the magnetic field line will occur? जब वो round होता है ना. So here if you take this tangent point, magnetic field will go like this. Here, you go like this. Here, you go like this. Here, you go like this. So like the tangential direction it goes. है ना? So magnetic field will go in the tangential direction. Suppose if you have the straight current carrying conductor by using the right hand thumb rule. है ना? So that magnetic, the line integral of the magnetic field B vector around any closed circuit is equal to. So here you can take any kind of small segments also. So this is the B vector and the dl also will be the small element, है ना? BDL. है ना? So BDL in the same point only it will occur. So circuit line integral of magnetic field with the current element is equal to mu naught times. Mu naught means what? Permittivity or permeability? Permeability. So mu naught is the current I enclosed in the circuit. So if we remove the dot, so what I have to write? If I remove the dot, what should I write? BDL cos theta. So if it is cross is there, then what I have to write? BDL sin theta. Cross है तो sin लिखना है. Dot है तो क्या लिखना है? Cross लिखना. Okay, take the cross. हो गया?
Yes, sir.
Yes, sir.
Answer.
Okay, बेटा. Yes. So Naresh, just photo ले लेना. Time हो रहा है ना, please. अबरा, photo ले ले. Okay. So now proof of Ampere circuit law. We are going to prove. There is Ampere circuit law is correct. Now can anyone tell me magnetic field due to straight conductor? What's the formula we get? What I taught you from Bayes law? Magnetic field due to straight conductor. Magnetic field. Anyone? Now, proof of Ampere's next topic. Take a straight current carrying conductor. Imagine that the current is moving. And what is the magnetic field? Magnetic field will go around the current carrying conductor like this. Okay. So this is the current carrying conductor. How the magnetic field will go like this, like this. So goes like this, anti-clockwise direction will go. Imagine that I'm taking a small element dl here, and at this particular point, how the magnetic field will occur in this direction. So this is the magnetic field direction and small element dl. Imagine that the radius I'm taking as r. The distance is r. Consider a straight current carrying conductor I from Bayard Savart law. We know magnetic field due to straight conductor. Yes, बच्चों जल्दी पढ़िए. What is the magnetic field due to straight conductor? What is the equation we get? E equal to from Bayard Savart law.
I by
You know
4
I
by 2 pi r.
2 pi. हो गया? हो गया? हो गया? So consider a straight current carrying conductor I from Bayard-Savart law. From Bayard-Savart law for straight current carrying conductor. Already we did this. From Bayard-Savart law, we know P vector due to straight current carrying conductor. That is, आपको याद आया? This derivation is not there. बोल के मैंने एक derivation मैंने करा था ना यहाँ पे. We take the point here and we make the angles phi 1, phi 2. Do you remember this? This question do you remember?
Yes.
Yes, sir.
sir.
So इसका formula we got that P vector will be equal to mu naught I by 4 pi a into sine phi 1 plus sine phi 2. So in this derivation, we take this as 90 degree. So sine 90 plus sine 90 1 plus 1 2. So 2 by 4 get cancelled. Mu not I by 2 pi r or 2 pi a. Both you can use. Now we are going to do proof of Ampere circuit. So what is the Ampere circuit law? From Ampere law. From Ampere's law, line integral of d vector dot dl. Not dl. So left hand side is d vector dot dl. है ना बेटा? So what is this? D vector को बाहर निकालो, magnetic field due to this straight current carrying conductor, और integral यहाँ पे डालो, और dl length of the segment. Okay. Now what is d vector? तो आपको पता है mu naught I by 2 pi r. Integral dl, what's the answer? Integral dl.
L.
L. Very good, children. L. So what is the length of the circle? What is the length of the circle? What is the length of the circle?
2 pi r.
2 pi r. Very good. Very good. So length of the circle is 2 pi r. Therefore, mu naught I divided by 2 pi r. For b, I substituted this value. B का value substitute करिए. Integral dl is L. So L, what is the length of the circle is 2 pi r. So then they cancel. So we get mu naught I. So if you see the circuit integral of PDL will be equal to mu naught times I. So we prove the Ampere's circuit law. समझ में?
Yes, sir.
Yes, sir.
हो गया बच्चों?
Yes, sir.
Clear up the board?
Yes, sir.
Now take down. Next topic is solenoid. Now, Canada? Yeah. Hey, solenoid, I taught you. Hello?
No, sir.
No, sir, not solenoid.
Take down, bachcho. Solenoid. Take down. Solenoid. It is an insulated. It is an insulated of is an insulated copper coil wound 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 in the form of helix. Wound in the form of helical. That means this solenoid. Okay. So this is solenoid. Now, bachcho, what is solenoid? Still, we'll go a little bit deep. Okay. Now, listen here. So, I'm going to just to draw the solenoid diagram there. Okay. So, you might what is the meaning of that? Can you tell me? Arey bachcho,
Rod means it is going inside.
current or magnetic field. Current or magnetic. Whatever you take, it comes out. So, if I put cross, what's the meaning? Arey bachcho, if
Going
you put cross,
inside.
current,
Inside.
whatever you consider. If you consider current you should say. If you consider magnetic field you should say. Right? But that means coming outside. Cross means going inside. So therefore, beta, I'm taking the wire line. Okay, that means from here it goes like this. Okay, from here it goes like this. Getting my point? From here it goes like this. So that means if you see that, this is all these things you see outside coil. It is a coil. Get it like this. Like imagine like this coil, round coil, helical part. Understand? So that is a coil. Now, you know that is the current is coming like this in this direction. You can put if you want arrow mark also. Now tell me, if I keep my right hand thumb rule like this, current is coming out bolana. So current is going inside bolana. And so my thumb shows this direction. Na? When my thumb shows this direction, so we take this part as a north pole. So magnetic field lines will go in this, or you can say magnetic field lines will go in this direction. Therefore, what's here? So my four fingers are in this folding direction, and then magnetic field line will go like this. Getting my point? So this direction where the thumb shows, that direction we take usually as north pole, and this we take as a south pole. Okay. Okay. How the magnetic field line goes? Can you say? Can anyone tell me how the magnetic? If I consider this as a north pole and this as a south pole, can you say online children how the magnetic field line I have to draw?
From north to south.
Very good, boy. From north to south. Plus,
Sir,
wrong. Actually, wrong. This is wrong. Sorry. Anyone? Online, jaldi boliye. If I take this is the north magnet and this is the north pole, this south pole, how the magnetic field line will go?
sir,
Jaldi boliye. No.
around it, many magnetic field lines will be there.
Okay, many. One line you say. Forget about the many. One line बोलो कैसे जाएगा बोलो कहाँ से कहाँ तक जाएगा गर्ल्स
Sir, from left to right.
मैं मोबाइल ऑन करके म्यूट में डाल के मेरे को पार्टिसिपेंट लिस्ट बता जल्दी बोलो अच्छो 6th standard boy will do the
Sir,
experiment
from left to right.
From left to right. Very good boy. This is the left side, this is the right side. So from left to right we go like this. Fantastic boy. Give me the participant list again. दे दो म्यूट में डाल नहीं आया ना मंकी Left to right. Totally any one girl. Any one girl. We mute her volume. So they can ask the student who is sitting there. Only participant list you show me. जल्दी बोलिए बच्चों. This is a magnet. How the magnetic field? This is the north pole. This is the south pole. How the magnetic field will go? Okay, go and sit. Come. Atifa,
Yes, sir.
जल्दी बोलिए. Shaidali is not there. Actually taking leave. Samyukta, Pooja,
Sir, will it go outwards?
you go. अरे बच्चों, okay. Forget about the magnetic field. You come to the first chapter. If I take the positive charge here. If I take a negative charge here. Now you tell me how the electric field will go.
Positive to negative.
Positive to negative.
Positive to negative. Very good, student. So positive to negative. Positive to negative. Very good. So you said that positive to negative it travels. Good. Now here you tell me like this. This is the electric field line. You said positive to negative. Here you tell me. This is another one mark question. If they ask, what you will do?
तो north to south ही जाएगा ना.
South to
North to
north.
south है ना?
Very good, children. Now only you got the point. So north to south, outside the magnet. North pole to south pole, outside the magnet, and south pole to echo हो रहा है. ये मैं mute करा बोला. South pole to north pole inside the magnet. So बच्चों, north to south outside the magnet and south to north inside the magnet. This is the magnetic field line. Please note down. These are all the basic knowledge you should have. Okay, now listen here. The magnetic field line from north to south it goes like this, and then north to south. Okay, so north to south it goes like this, and the center goes right. Now this solenoid behaves as a magnet. This solenoid behaves as a magnet. Now we are going to do a derivation. जल्दी हो गया? Just small diagram. Solenoid का diagram. Okay. Okay, बच्चों. All the girls, boys.
Sir.
Yes, sir. Done, sir.
Yes, sir.
Now
Okay,
derivation
sir.
take. Derivation करो. एक 3 mark का derivation होता है. Derive an expression. Derive an expression for the magnetic field. Derive an expression for the magnetic field. Derive an expression for the magnetic field. Okay. Point P due to long solenoid. So this is a 3 mark derivation. Derive an expression for the magnetic field at a point P due to long solenoid. First we'll do the long solenoid diagram. बच्चों. So you know pretty well what is a long solenoid. So if I take the dot here and if I take the cross here, so you know from the dot, that line I didn't do because you get again still confusion if I do like this cross line. If I put means again you'll get confused, more confusion. So I'm just putting the dot. That means the wire is coming out and cross means the wire is going inside like this. So it is a long helical solenoid. It is a long helical solenoid. We know as per the right hand thumb rule, if you keep like this, see the current is coming out, dots out array, and then the folding finger goes in this direction, so the current is going inside. So current is coming out, current is going inside. Current is coming out, current is going inside. Coming out, going inside. Like this, the current is traveling. Okay, when the current travels like this in circular orbit form, then the magnetic field will go by using the right hand thumb rule. So this is the current direction and this is the magnetic field direction. So all the magnetic field will be like this. Now the question they are asking you, if this is a long solenoid you have taken, if you take a point P here, if you take a point P here, so inside the solenoid you have taken a point P. So what is the magnetic field at this particular point P because of this long solenoid? This is the question. So try to understand the question. Okay. हो गया बच्चों, diagram हो गया?
Yes, sir.
Yes.
So consider a long solenoid. Consider a long solenoid. We wish to calculate the magnetic field at point P. Small introduction. Consider a long solenoid. We wish to calculate the magnetic field at the point P. Khalas, that is the introduction. Okay. Now, do you remember the first chapter, electric field? Suppose if I take a thin spherical shell, gas ka fourth application. If I take a thin spherical shell, if I take a point P outside the shell, so from the point P, what I did,
Gaussian
around the
surface.
point P, what I did? Very good, Abhidan sir. So I did that Gaussian surface. I made an imaginary surface. That imaginary surface I called as a Gaussian surface. Yeah. So like that, here around the point P, I'm going to construct a loop. That loop is called Amperian loop. What is the name called? Because we are going to use the Ampere circuital law. So I'm going to construct a loop around the point P. So what loop I'm going to take? I'm going to take a rectangle. Imagine the rectangle. Okay. Take loop and give the name A, B, C, D. So this idea of getting the training for the okay. Construct and imagine Amperian loop around the point P. Hello. Up to this, you understand, all of you? Jaldi boliye. Construct an imaginary Amperian loop around the point P, A, B, C, D. Like we did in the first chapter, around the point P, we did the Gaussian surface. So first chapter में है ना? So here what we do the Amperian loop by using the Ampere circuit law. हो गया बच्चों?
Yes, sir.
Yes,
Yes,
sir.
sir.
The introduction everything.
Okay, sir.
Yes, sir. Yes, sir.
So what's our aim? Abba, what is my aim? What is my aim? My aim is to calculate the magnetic field at the point P. That is my aim. है ना? So from Ampere circuit law, we know. है ना बेटा? तो Ampere से हमको क्या बोल रहा है? Line integral of B vector dot dl vector will be equal to mu naught times of है ना? ये बोल रहा है यार. तो ये बोल रहा है हमको Ampere's law है ना? Now we are going to apply this Ampere law. In this loop. So this loop is called Amperian loop. So for this particular loop, we are going to apply. There are two things there. One is left hand side, another one is right hand side. So left hand side, the B vector dot dl vector is there, or you can say BDL cos theta. You know? So taking left hand side, taking LHS. So first we take the LHS, we solve, and then we take right hand side. Okay. So first we take LHS. So circuit integral of d vector dot dl vector for applying the loop. So क्या है therefore this circuit line integral means this complete circuit means for this circuit we have to apply. You know? So first you put integration from where to where. I'll take this from here A to B, B to C, C to D, D to B. So A to B, A to B, A to B, like this. B, DL cos 90 degree because the DL what we are taking A to B is a DL and magnetic field will not change. Magnetic field का direction कभी नहीं change जाएगा. लूप में देखो बच्चों magnetic field कभी नहीं change होगा. Magnetic field का direction positive x axis है. But you see the DL what you are taking the DL AB is with 90 degree में. But here you see the DL BC is parallel. Or again you see the CD is perpendicular. Or you see the DA is DA कहाँ है? DA parallel है. But parallel है anti parallel है ना? Anti parallel. समझ में आ रहा है? Okay. Now first I'll teach you the concept. Then I'll do the numeric. Okay. Then I'll do the listen. All of you listen. Pay attention here. Pay attention. See, there are two things there. Left hand side में है line integral of PDL, P vector dot DL. Right hand side में है mu naught I. So I am going to apply this V vector dot DL vector for this entire loop. है ना? So for first thing is line integral of PDL. Left hand side I have taken. So for this means this is the complete circuit. है ना? For the complete circuit, for these two letters I have to apply. BDL we have to apply. So first you see that. So AB is perpendicular to magnetic field. BC is parallel. BC, B to C you watch. B to C carefully you watch. This element is parallel to magnetic field. Out the CD perpendicular to magnetic field. Out the DA anti-parallel to magnetic field. Are you getting my point or not? समझ में आ रही है? Suppose if you take this length as L, so B to C you take length as L. Okay, this is also right to the diagram. Now one by one I will say. So A to B if you write A to B is perpendicular now. So what I should write? BDL cos 90 plus internal. Then you see B to C. बोलिए BDL. What should I do?
Cos 0 degree.
Cos 0.
Cos 0.
Cos 0 degree. I mentioned therefore they replied very fast. Plus then internal. I'm going to A to B हो गया, B to C हो गया और C to D. Tell me BDL.
Cos
Cos 90 degree.
90 degree.
Very good. Plus integral D to A. BDL बोलिए cos
Cos 180 degree.
180 degree.
80.
180 degree. Magnetic field is in this direction, DL is in this direction. Same. So cos 180. Now, देखो बेटा यहाँ पे very important concept what we are going to learn here. What is cos 90? What is cos 0? What is cos 0?
Cos 0 is 1.
1.
Cos 0 1. By using mathematics knowledge, you will say here cos 0 is 1. सही है? By using your mathematics knowledge, you will say cos 90 is also क्या बोलेगा? Cos 90 क्या है?
0, sir.
0. Very good. So the whole term will become 0. This whole term will become 0. Sorry, this term will become 0. This term will become 0. है ना? So 90, wherever the 90 is there, that will become 0. And I am going to say 180 is also becomes 0. What nonsense is? Cos 180 is what?
Minus
-1.
1.
Cos 180 is -1. So here it will become minus BDL, है ना? यहाँ पे क्या actually आना है minus BDL. But I am
Minus
saying the whole term is 0. Why it is 0 means what is the concept says magnetic field line outside the solenoid is 0. Magnetic field line outside the solenoid is 0. Why magnetic field line outside is 0? Because current is not there. Why current is not there? Why current is not there?
The coil is in the
How
inside.
you are showing the finger like this, na? Therefore, here the incoming current, है ना? This in this point if you take incoming current, और उसका opposite side है तो outgoing current. समझ में आ रहा है ना? Incoming current, outgoing current. So it get cancel each other. Therefore, the element nothing gets current. So magnetic field is 0. Understand? This concept we are there. So how many terms become 0? This cos 90 term will become 0. This cos 90 term will become 0. And this cos 180 minus BDL will also become 0. Because here we say magnetic field is 0. Getting my point or not? Therefore, we get only one term BDL that is B to C term only will get. So write down here. Therefore, what is the left hand side? Since you don't need to write, for your knowledge, you are taking electricity, so you are not confused. Okay? If you don't write, otherwise you will get confused. So, taking LHS means this LHS I am solving. Okay, getting my point, and then you don't write. So I put here like this. Now, so integral, this term will become 0. So no need to write. I'll just write here as 0 plus integral b to c by dl. So only this term only will be there. The remaining terms will become a 0. This also will become a 0. After Nicola, if you don't understand this, you write down. Say magnetic field equal to 0 outside the solenoid. Outside the solenoid. Why? Because current is 0. Okay. So this is over.
Yes, sir.
Done, sir.
Okay, बच्चों.
Yes, sir.
Pooja, Mahi.
Sir, done, sir.
Ifa.
Done,
Atufa.
sir.
Atufa सो रहे हैं आराम से सो रहे हैं बिरयानी खा लेके.
Done, sir.
Atufa Zohar happily sleeping. Hello. Okay, Pooja over. Mishwa.
Yes, sir.
Okay. Now listen, bachcho. So very carefully listen. So only one term is left out. That is BDL cos 0. Okay. So that alone I am going to take. Remaining all the three terms will become 0. Therefore, next line you write down. Therefore, integral B to C I get. B to C. B here only. Remaining all the terms 0, 0, 0. Correct? So therefore, इसको बाहर निकालो. B बाहर निकालो. Integral B to C. Here. What is integral here? L. And B to C is values here. So BL. BL is the answer. Left hand side what is the answer? BL. Left hand side what is the answer again? BL. Now write up. Then in the conductor, in the length B to C, the number of turns of the coil BL. Carefully watch here. B to C, अरे भाई B to C इतना तक लूप लिया ना तूने. तो ये B to C 2 मिनट डॉट्स भी दिए. अरे भाई 1 2 3 डॉट्स यहाँ पे दिख रहा है तेरे को. तो यहाँ पे 11 डॉट्स पहले से. So that means one ring will be there ना. है ना? So I am writing here. Then in the length BC, the number of turns of the coil will be N. समझ में आया? Therefore, current will be equal to N terms of N. Current will be equal to N terms of. समझ में आया? तो करंट अगर क्या करना है, आप सबसे करना है N भी मल्टीप्लाई करना है. Clear of the board?
Yes, sir.
Yes,
So current will be equal to N IN. This current will be equal to this current will be equal to N IN. No need to put here I again. If you rather फिर भी रन हो जाए. तो यहाँ पे B to C एक छोटा सा एलिमेंट में कितना करंट जा रहा है, कितना करंट जा रहा है, how much current is there ना? That if you want to calculate means what you should say. N number of turns is there. L is there, length is L you have taken. So N L multiply कर लो, current का value multiply कर लो. So N L terms of current will be. समझ में आया? So now you substitute there in the right hand side. Therefore, left hand side is BL W equal to right hand side is what? Mu naught. I का जगह क्या करना बोला हमने? Current is what? NL. Current is what? NL. समझ में आया? So NL get cancelled. Therefore, the magnetic field at the particular point P will be equal to mu naught times N. magnetic field due to long solenoid is E equal to mu naught times of Ni. हो गया बच्चों, जल्दी बोलिए. This is your final expression.
Yes,
Here
sir.
I'll put that.
Yes, sir. Done, sir.
Yes, sir.
Now there is a beautiful formula. One more formula is there. We have to understand. Magnetic field array daily. Magnetic field due to long solenoid. At this point P यहाँ पे है ना भाई. I take this point P here. I take the 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 point P here. अरे भाई, anywhere you take the point. Anywhere you take the point, the answer is mu naught Ni. What is the magnetic field due to long solenoid? Mu naught Ni. What they say from the center point. Is the center point. The is the center point. When you go, this is the magnetic field is everywhere is same. Everywhere is same. Magnetic field is everywhere is same. When you go at the end of the solenoid, if you go, then it becomes the value क्या होता है? Half होता है. क्या होता है? Half होता है. So half times, that is the concept. Special case we should remember. Half times of mu naught everything. So first you write down. First we can put it here. And the end of the solenoid. The end of the solenoid. इसका ग्राफ कोशा को ऐसा करना है. Center point you take as one. Center point. The point O. Or this is the graph कोशा. So magnetic field at the center will be constant होगा. इसके बाद आधा बनता है. So here it will become n by 2 half होता है. यहाँ पे भी. So this is the graph. Just you can do the graph. What is given in your NCERT book. P by 2. P by 2. This is a straight line. Full axis solenoid, axial solenoid is straight line. End में come होता है. Okay, it is going to come. Okay. Now formula. There is a beautiful formula. This formula, if you remember, you can do the numerical. Number of turns if I say. Number of turns मैंने बोला तो you should use capital N. समझ में आया? Number of turns per unit length बोला तो. Number of turns per unit length बोला तो. तो कैसे लिखना है भाई? Number of turns per unit length लिखना है. This also will be equal to small n. So if you remember this formula, you can do better than numerical. अभी दो numerical करेंगे based on. Okay. Number of turns means capital N. Number of turns per unit length बोला तो small. Now, one beautiful numerical. Do it and give me the answer. But please don't check the book. खुद देखते कैंसिल नहीं बोलना है बेटा. अभी तक सर ऋषित है नहीं है भाई. ऋषित है नहीं है ऑनलाइन में. ऋषि है.
Yes,
ऋषि
sir,
है
is
नहीं
there,
है.
sir.
हो गया है
Sir,
वो.
is there, sir.
Is he there?
सर मैं
Yes,
यहाँ
sir, is
हूँ.
there.
हेलो.
हाँ नहीं कहा है भाई. बाहर में बैठा है अभी तक नहीं. अरे नहीं नॉनसेंस.
Yes, sir.
अभी बाहर में बैठा है.
अजरबैजान में
नहीं सर.
अजरबैजान में है.
सर नहीं सर, घर पे पागल कुछ भी बोलते हैं.
A solenoid of 300 turns per meter. 300 turns per meter is a solenoid of 300 turns per meter is carrying a current. Is carrying a current of first boy should say, second girl should say. First boys. The length of the solenoid. Length of the solenoid 0.5 मीटर।
सर एक क्वेश्चन है।
पूछो बेटा। हाँ बेटा पूछिए।
नहीं, एक क्वेश्चन है, पूछ रही हूँ।
अच्छा दिया है दिस न्यूमेरिकल फाइंड मैग्नेटिक। Yes beta, first boy should give the answer for this numerical. Whatever the formula I gave you, use the same formula. If after boys, girl should give that. हो गया बच्चों। बॉयज ऋषि क्या कर रहा है भाई?
हाँ कर रहा हूँ।
जल्दी करो बेटा, आंसर बोल बेटा, जल्दी बोल बेटा, फटाफट बोल बेटा। Who will say the new answer? जल्दी बोलिए। What is the formula? पहला formula। Very good boy, very good Abba. So B vector for long solenoid, B vector for solenoid, B n। अरे बच्चों में आगे भी बोला था व्हाट इज स्मॉल एन। स्मॉल एन नंबर ऑफ टर्न्स पर
Number of
यूनिट
turns per unit length.
टर्न्स पर यूनिट तो दे दिया है वहां पे नंबर ऑफ टर्न्स पर यूनिट। हलवा जैसा दिया है ना, सिर्फ अपने आगे निकलना। देखो नंबर ऑफ टर्न्स पर यूनिट टर्न्स पर मीटर दो दे रहा है। तो बी वेक्टर विल बी इक्वल टू म्यू नॉट। म्यू नॉट का वैल्यू क्या है भाई? 4 पाई इनटू 10 टू द
10 raised to
पावर
minus 2.
-7। तो 4 पाई इनटू 10 टू द पावर -7। अरे बच्चों कांस्टेंट का वैल्यू याद रखना, अदरवाइज दे विल गिव इन एग्जाम आल्सो, डोंट वरी। तो नंबर ऑफ टर्न्स करंट कितना है भाई? 5 एम्पीयर। इसको मल्टीप्लाई करो ना गर्ल्स। व्हाट्स द आंसर गर्ल्स? तो 4 3 9 and
1.88 into 10 raised to minus 7.
Huh?
1.88 into 10 raised to minus 7.
1.8 into 10 to the power -7। सही है। One girl is being 1.8 into 10 to the power -7।
10 raised to minus 3, sir. 1.884 into 10 raised to minus 3.
1.884 into 10 to the power भाई का वैल्यू 3.14 है भाई, डाल लेना रे भाई। हो गया। तो 1.9 into 10 to the power -3 टेस्ला। वेरी गुड, करेक्ट। गुड गर्ल, करेक्ट। आंसर इज करेक्ट। नेक्स्ट क्वेश्चन। Little bit a small twist is there in this numerical. Okay. So first girls will say the answer, then boys will give the answer. Yes, solenoid of solenoid of length. क्या हुआ भाई? अरे 3.14 डालना है या 1.884 बोले ना? 884 into 10 पर -3 आएगा, चेक कर ले। Here 10 पर -7, but she is saying 10 पर -3. हाँ नहीं, आंसर सही है, चेक कर लो। परेश करेक्ट अपा सही है। Then do this numerical. Come. The solenoid of length 0.5 meter. Right? The solenoid of length 0.5 meter has a radius 1 centimeter. Has a radius 1 centimeter, and is made up of made up of 500 meter. Sorry, 500 tons. Tons. It carries yes. First girls, next boys. Neha is there. Neha, my friend Neha is there. भाई नेहा है नहीं है भाई? हाँ नेहा is there. Hello, Neha. Hello. Hello.
Yes, sir. Yes, sir.
Give the answer, Neha. फटाफट दीजिए। नेहा और दीपा, अब्दुल गनी, अब्दुल अंसार, अदनान। अदनान, सो जाओ। अरे अदनान,
यस सर।
यार उनकी देख जवाब नहीं दे रहा है भाई।
यस सर।
हाँ, हैप्पीली स्लीप।
सॉरी।
सो जाओ।
नो सर, I'm sleeping. I'm trying as
No
well.
interaction, nothing is there.
Sorry,
हाँ,
sir.
सो रहा। फरिया आराम से सो रही है भाई फरिया। माही, copying everything. Mahi,
Yes,
Sir.
sir.
Mahi, 4 chapters farm I didn't see Mahi till now. All the 4 chapters.
Okay, sir. I'll send you today.
Sir, hello, sir.
मोहम्मद हर्षद, नेहा, पूजा और ऋषि, संयुक्ता। संयुक्ता अच्छा सो रही है भाई आराम से। संयुक्ता, शरण्या, जायद, जायद
यस सर।
तो क्या कर रहा है भाई? सो रहा है अच्छा आराम से। कल एग्जाम है भाई।
सर नहीं सो रहा।
हाँ, tomorrow exam is there. Study well.
चल
हाँ
नहीं
बेटा,
है सर।
girls give me the answer. 3 point. Wrong answer.
So
Sir, is it
62.8.
6.28?
62.8 into 10 raised to 6.
Yes,
So
please.
6.
Slowly.
So 62.8 into 10 raised to minus 2
62.8
into 10 raised to minus 2.
into 10 to the power minus 2. The monkey.
So
Listen, the girls are giving the answer.
So that's the
How
same
much
as 6.28, sir.
Huh?
So 6.28 into 10 raised to minus 3 I'm getting.
The minus
Okay.
8 is.
sir, I'm getting 6.28 into 10 raised to minus 6.
हाँ बेटा, दो भी सही है, but why the difference is there for you? Huge difference is there. Where you did the mistake? How come? Where I think you didn't convert here. I think you didn't convert here. I know that you didn't convert it. So first, you do those who don't know, please listen here. We know magnetic field, calculate magnetic field for solenoid. Magnetic field for solenoid will be equal to mu naught times N. अरे बेटा small n नहीं दिया है, small n नहीं दिया है. So what is small n? Again you have to write small n will be equal to capital N by L. अभी दिया था ना, इसलिए मैं फॉर्मूला दिया था. तो देखो कैपिटल एन कितना दिया है भाई? आज सिर्फ कैपिटल एन देके छोड़ दिया हो, बराबर? तो 500 divided by Sabarish, length of student in length of student in 0.5. तो देखो इसको पहला सॉल्व करो. 500 divided by 5 into 10 power minus 1 is equal to 5 into 10 power 2 divided by 5 into 10 to the power 1. 5 cancel हुआ भाई, 10 cube n equal to 10 to the power 3. So this you should find out first. इसीलिए you got the huge difference. क्या है Sabarish? So B vector will be equal to mu naught 4 pi into 10 to the power minus 7. Can anyone give me this 4 pi the value constant function? They will do very cleverly. 4 into 3.1. Already they will solve this. How much? Mobile check that. नन्नांग 16 4 4 4 12.26 ना? अरे भाई 12 सही है? पक्का? So this also straight away summation ना very beautifully they will do like this. So no, they won't get stuck. So n equal to 10 cube I use 5 ampere. So देखो बेटा, beautiful children they will do like this. 12.56 12.56 into 5 into 10 to the power minus 7 plus 3 minus 4. हाँ, इसको देखो मल्टीप्लाई करो. b वेक्टर इन b approximately 12 जरूर हुआ ना. तो 16 12 जरूर 16 10 to the power minus 4. तो check that 10 to the power हाँ minus 4 minus 2 आ रहा है यहाँ पे. What we did mistake? क्या मिस्टेक करा है जल्दी बोलो.
Sir, 6.28 into 10 raised to minus 3.
6.2
8 into 10 raised to minus 3 MT.
16 is coming correct, approximately. But power line is missing. 10 to the power minus 3
Minus 3 is not minus 4.
minus 3 okay, okay.
So minus 6.
Is minus 3.
अरे 3 तो 6.2 बोल रहा है वो. This answer is correct. What the girls are given? What is the book answer? You check. What is the book answer? 6.28 into 10 to the power 6.28 into 10 to the power minus 3 test. This is the book answer. All of you please check. All of you please check. तो इसको चेक करके बोला बेटा इसको सही है बोलते. अरे बच्चों, अरे इसका यूज था. What is the correct answer? Is
So that one
हो
is
गया. This answer you are getting? This book answer you are getting?
Yes, sir.
Yes,
yes,
sir.
sir.
Then it is okay. Correct. Then it is okay. Then next numerical. Multiply. Four सर. कौन सा ये तो क्या हो गया? ये तो क्या? No. And beautiful. We are going to learn derivation. Small derivation only. Four. Four onion moving charge. Onion. Move charge. Magnetic. Magnetic. So bachcho again I'm telling you please concentrate line by line, word by word concept because we are going to get 12 MCQ questions. 12 MCQ questions tomorrow in the first paper. 70 marks. So 4 1 mark question that is assertion reasoning. Assertion reasoning. Then 5 to 10 marks. 7 3 21 marks. 2 4 8. This is also 1 mark. But case based study. Case based study or 3 5 mark question. Right, beta? So 3 5 marks. So don't go behind who is preparing the question. That is not material. So please 70 marks is there. And my sincere humble request to you is whatever the marks you get, immediately take the photo and share with me. So my Sharma Nami. Okay, whatever the marks you get, please share with me. Then only I can give you proper guidance. But I'm not sure, whatever I taught you till now, na, if you study whole honestly, and if you prepare MCQ a little bit more MCQ, 100% more than 65 you can take. Therefore, then challenge the question paper. Understand? But all the concepts should be thorough. Okay? Fourth one, yeah? Moving charge in a magnetic field. So draw the diagram, bachcho. First, if I take the charge here, first you charge here, and this they are taking as making conclusion of the diagram. First Q charge is here. Okay, x-axis, y-axis, z-axis. Now, this charge is moving in this direction. V velocity. This charge is moving in this direction with the V velocity. Imagine that magnetic field is also acting along the positive side. Now, bachcho, I'm asking one question. Imagine that x-axis में magnetic field is traveling. X-axis में magnetic field is traveling. Now, this charge moving in presence of the magnetic field, making an angle theta with the x-axis. making an angle theta with the x-axis. So this is the speed of the charge is v. Speed of the charge is v. This is the theta. That means what is this line? What is this line? I don't know. You should say. Yes, anyone in the online? If this is v, what is this line? What is this line? So first you tell me what is this line?
V cos theta.
V cos theta.
V cos theta.
That Shantanu only say after attending JEE class, immediately switch on. Even if it is 10 minutes also, he is attending. That is the point. That is the dedication. ऑनलाइन क्लास जेई क्लास अटेंड करके फिर देखो 10 मिनट है जी वो ऑन करके आके बैठा है तो if this is theta this will be v how many times I can this is 3 cos theta है ना तो ये लाइन क्या आता है
V sin
sin
theta.
theta.
डायग्राम पर लेकिन नहीं कहते हैं रेक्टेंगल एक पैरेलल हो गया
Yes, sir.
Sir, is that a proportional sign?
क्या बेटा
Sir, is that a proportionality sign?
प्रोपोर्शनल
Sir, is that a proportionality sign?
हां
Okay, sir.
हो गया
Done,
Yes,
sir.
sir.
हो गया
Yes, sir.
Yes, sir.
तो नाउ लिसन बच्चों तो v sin का इस ना v sin का यहाँ पे है ना और b कहाँ है भाई यहाँ है मैग्नेटिक लैम्प है ना so how you will fold the finger from b to b if you fold the finger imagine that b to b if you fold the finger b to b okay then the thumb shows in this direction na? So in this direction the force will increase समझ में आया देखो ऐसा देखो so this is in this direction इसका parallel ये है exact so if I fold the finger so v sin theta cross b getting my point v cross b so in vector form down in vector form what personally but if you know the form force is directly proportional to qvb sin theta these factors that's why force on a charge in a magnetic field force on a charge in a magnetic field will be equal to q v cross b because if sin theta what we should use hello
Cross product.
if
Cross
sin
product.
theta means what we have to use
Cross product.
Cross product.
cos theta means what we have to use याद रखो f is equal to q into V cross T. Now, special case. Three special cases there. You tell me by using your max knowledge. We know. Now, when you put special case, we know force on the charge. Force on the charge. We have equal to Q, V, Q, and V. Okay. First one we take. If theta equal to 0 degree. Yes, Bacho, tell me the answer. If theta equal to 0 degree.
Force is 0.
Zero.
Force is 0. Very good. So first case, if theta equal to 0 degree, that is parallel. है ना? Theta equal to 0 degree means magnetic field and the charge moving is parallel. No theta. Theta is नहीं मिला. Theta is 0 था. So first case is over. Second case. If theta equal to 180 degree or 0 degree.
Then also 0.
Theta equal to 0 degree तो हो गया ना. और 180 degree. बोल बेटा.
F is equals to 0.
Then also F equal to 0. Then also F equal to 0. Formula. Max का. बच्चों sin 0 0 ना. या 0 अप्लाई करें या parallel अप्लाई करें. 30 कर. Force मिलना चाहिए. along the magnetic field. Along the magnetic field area. Parallel जाओ and the force. But now see the third special case. If theta equal to 90 degree, बोलिए. बोलिए.
QVB.
So F equal to
That's what QVB.
F equal to QVB is nothing but F is maximum. F is force in the maximum. And it is perpendicular. So these three special case, please remember, don't forget. Okay.
Yes, sir.
Yes, sir.
Now, SI unit of magnetic field. You do yourself. Do it yourself. What question है ये? SI unit of magnetic field. MCQ question very important. About that question है. Many children they did wrong. Many children, even the JE students they did mistake. So what is the SI unit of magnetic field? जल्दी बोलिए. अरे बोलो ना बच्चों.
Tesla volt coulomb.
भाई A B C क्या था ऑप्शन दिया था. उसने टेस्ला दिया था. So majority of the children they put a tick mark in the A. So they get 0 mark. Why means there is one more unit in the SI unit. So वो जो भी दिया था ऐसे टेस्ला और बोल के लिखा. That point we have to put a tick mark. So we will do that. Okay. SI unit of magnetic field. What's the formula? F equal to Q will be said that. अभी क्या ना?
What is the cubic center? Yes.
We know. अरे उनकी देखो. We know F equal to Q will be sin theta है ना? अब ना बोला जाता. तो मैंने तो चाहिए ऐसे यूनिट ऑफ मैग्नेटिक फील्ड पूछा ना. तो मैग्नेटिक फील्ड ले लो भाई. मैग्नेटिक फील्ड को बाहर निकालो. तो F by
QV.
sin थीटा तो नहीं है ना. sin थीटा तो कुछ नहीं है. मान नहीं रहा है. रेडियन ना नहीं जाता. हो गया. यस इसको सॉल्व करके बोलिए मेरे को. फोर्स का क्या मेजर करेगा? फोर्स इज मेजर्ड इन टर्म्स ऑफ
Newtons.
force is measured in terms of online children. Force is measured
Sir,
in terms
for
of
Newtons.
yeah?
Newton.
Yes, a little bit of force. Oh my God.
Sir, Newtons.
Newton. Force is measured in terms of Newton. Charge is measured in terms of
Charge in the coulomb.
what is this letter? Velocity. Velocity का ऐसा यूनिट क्या है? मीटर पर सेकंड.
Meter per second.
मीटर पर सेकंड है ना? तो B equal to N by AM. ये कितना है? ये कैसा आया? यस ऑनलाइन। ये कहाँ से आया?
There is
Sir,
Sir, charge per second is
Coulomb per
current
second.
का
Yes, sir.
ampere.
Current
Very good boy.
current in
Very
ampere.
good boy. Samson, very good boy. Current I equal to Q by T. I equal to Q by T. So ampere, current is measured in terms of ampere. Charge is measured in terms of coulomb. Time is measured in terms of second.
Second.
तो इसको मैंने लिखा C S power minus one. तो यहाँ पे C S power minus one I am writing in terms of. Right? So B vector magnetic field will be equal to Newton per ampere per meter. This is what they have given as a option B. Tesla and Newton per ampere per meter. ये दो ही दिया था, ऐसा दिया था एक ऑप्शन और ऐसा कुछ दिया था और यहाँ पे दूसरा कुछ दिया था डी सी डी ऑप्शन. Most of the boys, right? Kavarish, most of the boys they put it in here. Tesla also correct. Tesla also correct. But they forget to check the second line. This is also correct. समझ में आया? So you should put a tick mark in B. B option में tick करना है. All the online children understand?
Sir.
Yes, sir.
Yes, sir.
Next topic.
Yes, sir.
Lorentz force. Take Lorentz force. Okay. Lorentz force. Right करना होता है. Combined effect of electric and magnetic is called Lorentz force. So what is electric force? पूजा electric force क्या है भाई? Define electric field. Force experienced by the unit test charge. याद आया? Long ago 1947 में पढ़ना. अरे पूजा के 1947 में पढ़ी electric field define electric field force experienced by unit test charge. क्या अभी इस नींद के चक्कर में है भाई? नेहा फर्स्ट चैप्टर define electric field. Yes. कौन है? अब आपका like ఏమిరా ఎందుకురా ఏమిరా మళ్ళీ పంపించి what is this पूछ रहा हूँ मैं. So define electric field. Electric field is the force experienced by the test charge. याद आया नहीं आया भाई?
Yes, sir.
Yes, sir.
हाँ. So magnetic force इसमें से force निकाल F equal to Q. Second part magnetic force. हाँ. Oh. This is not available for offline children, online children. Only offline children listed. So बच्चों listen here. This is the electric force. This is the magnetic force का formula. तो यहाँ पे लिखा हूँ मैंने combined effect of electric force and magnetic force is called Lorentz force. What is called Lorentz force? Lorentz force in a particular place, there should be a combination of electric force and magnetic force is there, means combined effect of these two forces is called Lorentz force. तो दोनों को combine करके लिख दो. Therefore, Lorentz force F will be equal to A equation और A equation. दोनों को combine कर दो. What is common? Q is common. Plus V cross Q. This is your Lorentz force formula. बेटा नेट फोर्स नेट फोर्स क्या होता है? नेट फोर्स क्या होता है भाई? करंट फोर्स विल बी इक्वल टू इलेक्ट्रिक फोर्स प्लस मैग्नेटिक फोर्स। समझ में आया? इलेक्ट्रिक फोर्स प्लस मैग्नेटिक फोर्स, राइट? तो दोनों फोर्स को ऐड करके कॉमन ले लिया। अंडरस्टैंड ना?
Yes, sir.
Yes, one beautiful numerical. How much time is it? आपने थोड़ा जल्दी छोड़ दिया मैंने, बाई मिस्टेक छोड़ दिया। अभी तो क्लियर है ना, नंबर से ना। An alpha particle,
कल भी क्लास होगा।
an alpha particle. If all of you want tomorrow also class means we will give class, offline class, where you want to come. अब घर पे आ जाएंगे. Tomorrow you want class, first you tell me that, all of you. But
Yes,
all
sir.
of you no need to waste our time. Just message me. If you want tomorrow class, complete revision from first chapter to fourth chapter means, tell me correct time exact. Wait. Tell me. Please, bachcho.
Sir, सुबह
If you
10
want
बजे
class tomorrow, also revision class. If you want full means from first chapter to fourth chapter. If you want the complete revision, formula revision, sub revision करना है तो particularly offline class, we'll go to above घर, okay? above घर पे जाएंगे. So mention the timing, message me. By seeing the majority, I'll keep the class. If you are not messaging means, then we'll close the class. Okay, this is the last class for this exam. And then never forget, online class will continue in the summer vacation. Already I told you, whether you are present or not, that will not be a big issue. Regularly classes will be there Tuesday, Wednesday. Okay, continuously online class. Tuesday, Wednesday only. मेरे भाई की सारा दिन विचार कर बैठा हूँ, मेरा फोन के साथ नहीं बैठा, यूजलेस लग रहा है। समर वेकेशन में मैं तेरे को लपट के पकड़ के बैठ रहा हूँ भाई। सर संडे क्या हुआ? सर सैटरडे क्या? ठीक है सबरिश। नॉनसेंस। Every time is asking me, an alpha particle is projected vertically upward. And is projected vertically upward. With a speed of Noah or Atupa, they will give the answer. The speed of 3 into 10 to the power 4 kilometers per second. Or in a region where a magnetic field of magnetic field is 1 Tesla. 1 Tesla exists. So find the magnetic force. Find the magnetic. हाँ भाई, अतुपा, अतीफा, लोहा. Give me the answer. जल्दी करो. हाँ, very good boy. Same formula use करो. Fantastic. Abrar gave me the formula also. Abrar formula बोल दिया भाई, जल्दी करो.
मैं सुबह ब्रेकफास्ट पूरा दोपहर में खा के नहीं सर पूरा ब्रेकफास्ट
खाने में पीने में कुछ शर्म होना नहीं. Yeah. खाने पीने में कोई शर्म नहीं. खाने में नहीं शर्म होना. पढ़ाई में है ना, जब भी डाउट आता है ना, पूछना है टीचर से. हमेशा पूछना. You feel shy ना, then you will go back. तो मैग्नेटिक फोर्स का फार्मूला जल्दी बोलो. F equal to QVB sin theta.
Sin theta.
Very good. So do it then. Substitute that formula में F equal to Q efficiency का substitute करो.
तो वो किस तरह लास्ट वाला v equals to e vector plus b vector b vector
Vector form. Same
तो
time.
ज़्यादा given value.
First to take the values. हो गया बेटा? Girls,
0.6 into 10 raised to minus 15.
0.6 into
10 raised to minus
10 power minus
15.
15. अच्छा. 0.6 into 10 power minus 15.
No, sir, 9.6.
Huh?
9.6. 9.6.
9.6.
9.6.
9.6.
Sir, I'm
Please
getting
check.
9.6 into 10 raised to minus 12.
10 power minus 12.
Sir, I got
Boys.
9.6 into 10 raised to minus 15 only, sir.
Okay. Or minus 15. अरे boys. अरे don't play. All of you check this. कैसे करो? An alpha particle is projected vertically upward. Is projected vertically upward with a speed of 3 into v equal to 3 into 10 to the power 4 meter per second. मीटर पर सेकंड नहीं किलोमीटर पर सेकंड दिया तो इसको कन्वर्ट करना है किलोमीटर पर सेकंड में दिया इन ए रीजन वेयर मैग्नेटिक फील्ड 1 टेस्ला एग्जिस्ट है ना इन ए रीजन वेयर मैग्नेटिक फील्ड 1 टेस्ला एग्जिस्ट इसमें कुछ एग्जिस्ट इन द डायरेक्शन ऑफ साउथ टू नॉर्थ सॉरी यहां पे बुलियन में व्हाट मीनिंग साउथ टू अदरवाइज वी कैन नॉट डू द थीटा south to north. You know that the social difference give you this is north means this is south. This is east means है ना? बता देते हैं. So north to south or east to west. East to west. Over. So that means so F equal to QVB sin theta. Alpha particle. Here is the twist is there. Here is the twist is there. Here is the twist is there. Several times I told you alpha particle जब भी physics में बोला तो what is alpha particle? First tell me what is alpha particle? What is alpha particle? Till 14th chapter remember this. If I say alpha particle, what is that?
2E.
2E.
2E, sir.
2 into
4 mass number 2
Yeah, monkey. 2He4 alpha particle is 2He4 helium atom. Alpha particle. So charge is if you see that
Charge is
plus
two
or minus
into-
equal, charge is equal to 2E. Charge is 2E. समझ में आया? समझ में आया नहीं आया? Therefore, now F equal to Q. 2E. 1 E is charge in the electron. 1.6 electron minus 19. Magnetic field 1 Tesla. Speed 3 into 10 power 4. तो करेंगे. Speed अब कितना दिया है speed? 3 into 10 to the power 4 किलोमीटर. किलोमीटर को मीटर कन्वर्ट करने के लिए into 10 to the power 3 ना into 10 to the power 3. Okay. Then sin theta sin 90. Sin 90. So tell me the 2 into 1.6 into 10 power minus 19. उसके बाद
Sir.
3 into 10 power 7 sin 90.
सर वो 9.6 into 10 raised to minus 12 है.
क्या बेटा?
सर आंसर 9.6 into 10 raised to minus 12 है.
आंसर वो वाला ऊपर वाला.
Okay. So I check the book answer. Yes, those children who said this answer is correct. Congratulations to girls. Atifa, Tufa, Zoha, congratulations. They said the answer. So boys' answer is wrong. This answer is wrong. Abhi's answer, Omer, you are wrong.
सर मैं तो 12 बोला.
Okay. Yes, बच्चों. So inshallah, see you next class. Okay. So tomorrow if you want, मैं क्वेश्चन नहीं हुआ. क्वेश्चन नहीं हुआ. बहुत बड़ा चैप्टर बोला ना मैंने.
एग्जाम में पूरा चैप्टर आएगा.
एग्जाम में पढ़ लीजिए थोड़ा पढ़ लीजिए. गैल्वेनोमीटर का थोड़ा है. गैल्वेनोमीटर का कॉन्सेप्ट आ गया.
सर मेरा दूसरा क्लास स्टार्ट हो रहा है.
So
Can I
please,
leave?
children, if you want tomorrow class at Abhav house, okay? That's what. You message me separately at what time you want the class. पूरा मेरे को detail भेजिए. If you don't want to, no problem, okay? But just message me. See you. Bye.
Sir,
Take care. Bye. See you. Bye.
Sir, one question, sir. Sir,
बोलिए.
for this exam, this is the portion over for this exam.
For this exam, full 4 chapter beta. But girl section से question paper आ रहा है. I don't know. Some this Atifa girl is there ना. One girl is there, Atifa, Mahi, girls, Malayalis, pura they are saying portion is very less portion they are saying. But I don't know.
Yes,
Maybe
sir.
the teacher,
My ma'am said less portion only, sir. My ma'am said less
that's
portion.
what. So please adhere to them because the question paper they are only preparing. I know that. So girl section से आने से वो लोग का question paper तो आप उनसे पूछ लीजिए. They may be saying that up to what portion? Tell me, girls. Once again, can you tell me? अरे बोलो ना यार, girls.
Hello, sir.
What's the portion they said to your teacher?
Madhurima
What is
ma'am
the
said
portion
that
they
it will torque on a current carrying coil.
Torque?
On current carrying coil. That's the last.
Madhurima told you.
Yes.
Then go with that. Okay. So that means galvanometer they are telling. Galvanometer is also a very good topic. Okay. Galvanometer छोड़ के up to they are saying that Madhurima बोले बोल के up to torque you study. Okay. Take care. Allah Hafiz.
Okay,
See you.
sir.
Okay.
Thanks,
Bye.
sir.